Hello everyone, welcome to another session of the DataHour series. We'll start in 5 minutes. Till then, let's get to know each other in the chat section. Hi guys, I can see Monali Roy, Paul Samuel, hi. Please, I would like to see some messages in the chat section. Hello Naman. Hello sir. Yeah.
Hey, hi.
Hi Vishnu. Hello. Hi Vaishnav. Also mention your location. Where are you from? It's good to know people from different parts of the world, right? Vaishnav from Chennai, yeah. Hi Narasimhan. Hi Srini from US. Hi Wahab. Oh, sorry if I'm pronouncing you wrong. Afghanistan, great, great. Okay guys, also I'm going to launch a poll. That poll is about your location and experience. Please try to participate. Na? Please guys, everyone try to participate in the poll. Hi Vikas from Mumbai. Okay, guys, let's start. Okay. So I would like to welcome everyone to another session in the DataVerse series. We are also thrilled to be here with you this evening for a session full of action-packed learning. So I am Tamil Selvan Murugeshan, part of the data science team at Analytics Vidhya, and I'll be the moderator for this session along with Shreyas and Ram. Okay, for those who have joined for the first time, let me give you a brief introduction of what is DataVerse series. The DataHour is a series of webinars conducted by Analytics Vidhya and led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members and learners. So now on to our session today, which is computer vision landscape. So computer vision is evolving from the emerging state and the result is incredibly useful in various applications. The main purpose of computer vision is to make computers see and clarify the world like humans or maybe better than us. In this data hour, Mr. Naman will demonstrate how to take up any new computer vision related problem and solve it using the prominent CV components. I hope you are excited to attend this data hour with us. So before we kick things off and I hand it over to the speaker, a quick recap of the housekeeping things. We are recording the session and we'll make the recording available in a few days on our YouTube channel. Please use the question and answer section for asking any questions you might have during the session. And we'll try to do our best to answer them as the data hour progresses towards the end. Also, we'll share a poll about the feedback of the session towards the end, which I request all you to kindly fill up as it will help us to come up with more such sessions. Okay, now on to our speaker. In this session of DataHour, we have with us Mr. Naman Bayani. Mr. Naman is passionate about building AI systems to solve real-world challenges. His primary expertise lies in the field of machine learning, deep learning, computer vision, natural language processing, data science, and Python software development. Currently, he is a research engineer at Jupyter, where he is building a large-scale data mining platform. Previously, he has worked at Geo as a deep learning engineer. Over to you, sir. The virtual stage is all yours.
Hello, thank you everyone for joining. And firstly, thanks to Analytics Vidhya to give me this opportunity. I read the blogs, as you know, as most of you guys would have been doing most of the time from Analytics Vidhya, and it's a great source of knowledge, right? So, can I share my screen now?
Sure, sir. Sure. You are good to go.
Yeah. Okay, I think it's disabled. It's the host has disabled for
Yes, sir.
screen sharing.
Yeah, you are good to go. Can you share now, sir?
Yes, thank you. So let's start about today's session. So basically, we won't go into much details of from the algorithmic perspective. The agenda for today's call is to just show you things, get you excited, and then try to deconstruct prominent products. That how they could have been built up from ground up. And this would be an oversimplification for some of the products, but the idea is to give you some sense of how we could try to build such systems using some prominent CV components, right? So a little bit about myself. I started in 2017 working with a robotics company. There I was building ADAS system, which is advanced driving assistance system. So our product was a driver state monitoring system, which continuously monitors truck drivers and everyone. And if they fall asleep, we raise an alarm. And there have been several instances. We record all these streams in real time. So we actually see a lot of times that people, drivers are just drowsing off, and suddenly, because our system has raised an alarm, they would suddenly wake up and then drive the truck to a safer place. So that kind of gives us a satisfaction that okay, whatever we are building, it is saving lives, right? So that was about my first company. So moving on to Geo, we built several products, deep powered by deep learning. So for example, very scalable face recognition based access control system. So basically, imagine a building where say 5,000, 10,000 employees are working. Okay, and generally in all the buildings you have RFID cards to give you entry, exit, mark attendance. So we built face recognition systems at such scales, and not just one buildings, many warehouses, right? All basically think about Reliance scale, like it is spread across India. So we have deployed several systems for face recognition, and imagine a mobile phone with face recognition system. It is just one to one, right? You have to map one person to its reference image or face. But imagine a scale where your system have to be perfect for thousands of customers. So there you would always think about, okay, precision recall and all those things. But yeah, that is the scale at which we have to build the systems for production. Then secondly, like ANPR systems, for example, whenever a car is coming into the campus or warehouse or anywhere, right, we have to actually log and display that, okay, what is the number plate of the car, is it registered or no, something like that. And you all would and coming to Geo Cinema, it's like uh, imagine Amazon X-ray feature, right? That you are seeing the movies, and at the same time you are seeing all the celebrities which have been showcased in that particular scene, right? And it comes in at regular interval that, okay, is scene mein there is Shah Rukh Khan, there is Aishwarya, etc., right? So similar feature we built for X-ray as a Geo Cinema and deep synopsis engine. I would give some demos here. And mostly, the most exciting part about the entire thing is the MLOps pipeline. Basically, if you build a normal system which is say running on just your laptop or something, it is just a POC, right? It does not have any business value, and that is the major issue with most of the computer vision projects, that they just die down at a POC level, but it's very hard to scale up and productionize it. So yeah, like the productionization part of all these CE based products running say 100 plus concurrent streams on one server, that gives you the real pick that, okay, this system is working great, but it's also scalable, right? Otherwise, these are very expensive systems, right? So that's the thing. And coming to Jupyter Money, like for with high tech robotics and Geo, it was mostly about computer vision. But with Jupyter Money, I'm totally focused on NLP based products. So like crunching say about 30-50 million data points for users, every day, and getting insights on top of it. So that is the scale. Basically, if you are building any system, it should always be scalable, right? That's the point. And if it's powered by AI, then great. Yeah, so now we'll, of course, when we talk about computer vision, so first thing which comes to mind is autonomous cars, right? So we'll try to deconstruct on first we'll try to see that what Tesla actually observes, in real time. So here's the video. It'll take 30 seconds. You all can watch with me. So, these are all the kind of signals which Tesla gets in real time. That whenever it is driving autonomously on roads and everywhere. So, so many signals it is getting that, okay, there is a car in front of me. Where is the lane? Where is the stop sign? All these things. So, just a second. So now let's try to deconstruct on what could be, what are the models, probably which could have been used in Tesla's system, right? So firstly, what we see here is a car, right? Or car or a truck. So it tries to, locate that, okay, where is the truck, situated? What kind of, is it a car or is it a truck or is it a scooter, right? So basically, this is an example of object detection. Okay. Then secondly, you see these lines, okay, green line, red line, the curvature lines, okay, these white curvature lines and all those things. So what can we basically, what does it signal? Like what kind of system could give such accurate lines कि अच्छा मेरा road कहाँ जा रहा है, right? these kind of problems. So basically the idea which comes to mind that okay, perhaps there is a segmentation model, image segmentation model running in background, which is able to exactly give me that pixel perfect data, that where what is the location, exact location of my road, how is it changing directions and all those things, right? Thirdly, again, the car could be one object, but one other object which we see here is a stop sign. So it is trying to locate that, okay, there is a stop sign here. So perhaps it's a signal that, okay, we don't have to move here, there, etc. So that those kind of, basically, once you get these signals from the image, then you can try to make some decision whether we have to stop or we have to move, etc. Right? Now, other thing is, apart from this entire thing, what other interesting things we can see is few things which are written down or written on the image itself. So let's look at this part. So what is actually shows is blinded, raining, you know watery road or something, restricted control access, and it is marking green as raining. Then it is like a wet road, right? So what could this indicate? So essentially, it it is probably, I am just trying to oversimplify the problem. Perhaps it is, but we are just giving a hit at what probably could be the models running in the background. So probably from this entire image, it is trying to classify whether it's a and it's a multi-class classification essentially, because one single image could have multiple signals. So essentially within this image, it is saying that okay, it is raining and it's a wet road, right? Now, second, lastly, as I talked initially, that it's all about scale and performance. That now, with Tesla, it's always real time. So real time में video आ रहा है, okay, and you have to make decisions instantly. It's not like a batch processing job that okay, you will get some video, then you will take say 1 hour to process and make some decision. No, every decision have to be in real time. So that's why FPS, what FPS means is frames per second. So what here it shows is that the FPS runtime of this system is about 7 to 18, frames per second, which is great, right? I mean, running so many models in parallel and sequentially, I mean, not sequentially, but parallelly, and giving such a great performance is great. Then there is draw FPS. So essentially, we it is also drawing all these kind of bounding boxes and edges and everything in real time, right? So that also gives you some computational cost. So there is a draw FPS, then there is the display FPS. Now, what there is also something else we can see here, that okay, calibration PYR. So PYR, what could PYR mean, right? So it is essentially your pitch rule. So in any vision based system, we always think about that, okay, what is the deviation or what is the angle at which probably we should move, okay? Basically, if anyone has ever read about any drone based systems or say flight based systems, so your pitch roller essentially the angles in 3 direction, right? So yeah, that is also some information which we are getting here, right? This I'm not exactly sure what this could mean, but from this picture, I mean, are you getting a broader idea on what could be the models probably running behind the scene? Essentially, it's a mixture of three things: classification, object detection, and segmentation, right? That is the basically thought which I want to drive here, that there are three kind of components, essential components. One is the classification, one is object detection, and the third is segmentation, right? Only three. We'll keep repeating this throughout the session, but yeah. Now let's talk about Google Lens. So if you ever tried Google Lens, it is really accurate. I mean, you take a photo, then you essentially you get all the similar or recommended products or images online. So what essentially could be running behind the scenes? So you know this is a very special case of object image search and retrieval. So essentially it's like you take a photo, you do some cleaning, pre-processing, etc. Finally you create some embedding, and then you have a very large DB of all the products or images with their embedding stored, and then you then you search for those embeddings within that database, right? I mean, I'm just trying to oversimplify the problem, but this is what could be one solution for this problem: image search and retrieve. And during lockdown, like 2020, I tried to take a stab at, can I actually build a fashion AI search engine on my own, right? So here's a demo. I mean, unfortunately, I have taken down the website. It was giving me a lot of computational cost. So yeah, but I have a video. Let's try to see this. Now I'm trying to predict that, okay, what are the different products, which are similar to these images, right? So I say that, okay, floral hair. Then when I click, I am redirected to Mintra, which says that, okay, ये ठीक है, right? Then I try to upload an image or click a photo, right? And then it says that, checked red floral short sleeve. So these are the predictions I'm getting. Okay, I'm printing the predictions here, and then I'm seeing the buy similar products. So essentially, this is a retrieval system. Okay, so let me take you back a bit. Okay, so here you can see, right, I am printing the predictions that it's a floral shirt. Okay, floral pink. So pink is the color, and the kind of top, it says that, okay, it's a long sleeve top, right? So essentially, using these final features and embeddings, etc., I try to retrieve that, okay, what is the most likelihood, or what is the most similar image from my scraped database of Mintra products, right? So now it says that, okay, these are some relevant images, or not images, sorry, relevant products. And when I click on buy, I am redirected to this page. So yeah, essentially we were just experimenting. I mean, it was lockdown, we had free time. So me and my friends, we thought that, okay, let's try to build such system, and we'll see if we can really create a business out of it. But yeah, we had to take it down. So that is a essentially what I'm trying to drive here is, this system also we had built using essentially two components. One is the object detection component, which tries to detect different body parts, or say face also. Okay, so basically here we are also trying to classify, or say whether it's a male or a female. Okay, that is a first big filter criteria, that, okay, agar if it's classified as a male, then you don't really have to search in products for a male person, right? Then it tries to extract different body parts, whether it's upper body, lower body. Then it tries to, within those localized areas, then it tries to classify that, okay, is it a long sleeve or a short sleeve? Is it, what is the color of this product? What kind of pattern? So is it a floral? Is it checkered? All kind of different semantics. I hope it is making sense. So essentially there are two components. One is object detector, second is the classifier. Okay, now this is one of the products which we were building at Geo. So it's like a deep video synopsis or a deep search engine kind of. So the main motivation behind this product was there was a very huge bomb blast, London bomb blast, many years ago, like 3-4 years ago. And essentially there was a system. Basically everyone knew that, okay, there is a lady who had worn yellow clothes. Bas utna hi pata. They just knew that there was a lady with who had worn yellow clothes in the railway station, and we have to search her. So they just took all the CCTV camera videos and everything. They just dumped into a system and just asked that, okay, give me all person who were wearing yellow clothes. Okay, this was one motivation behind building such surveillance system. So so first part, again, coming back to the basics. So first we have to have a detector model which detects different body parts of a person. So here you can see there is a face, there is upper body, there is full body, then there are lower, say red would be say lower object body part, lower body parts, etc. Okay, then second could be the attributes model, that, okay, given these different body parts or objects, etc., what are the different attributes? So pardon for the bad image and also, but essentially I am just printing here okay, is it a blue shirt, is it a long sleeve shirt, or is it a say is it a male or a female? So all kind of a laundry list of features which we had decided, I'm just printing out here in some way. Then the third part could be that okay, I just put, there is some incident and I just want to uh, I know that okay, there is one person who has stolen something from the shopping center and he was wearing white clothes. Okay, so I want to search for all people who have worn white clothes. Okay, so then let's take this synopsis video. So essentially here I'm trying to uh, show all people who have worn white clothes. I hope this makes sense. uh, and here there is constant tracking, so there is again object tracking. Okay, so yeah, tracking is also one component, but I have not covered it. But yeah, once you detect an object, you have to track it. So object detection, object tracking, classification, right? Basically using these two three components, you can essentially build most of the computer vision based products. But yeah, I'm just trying to oversimplify things. There is a lot of work which goes into building these models, but yeah, I hope it is making sense. Yep. So yeah, so then one next example is automatic number plate recognition. So again here you have to detect a car, you have to detect the number plate, and once you have localized the number plates, you have to build some OCR based model. I mean, we'll not go into details about how to build these models, etc. But essentially, we have to have some OCR based model which can predict that okay, what is the number written in this car. So again, essentially, you have say object localizer or a detector, then you have say a tracker, then you have classification, not classification, sorry, OCR model, right? So basically, these few components. Yep. So summarizing again, classification, detection, and segmentation. If you know how to build these, models of these three categories, you can essentially build most of the products. Okay. If you have any doubts on this, you can ping and we can discuss, right? So again, repeating classification, detection, and segmentation. Yep. So some fundamentals that okay, how do these you know models or some systems, how do they actually predict, right? So essentially think about it like if you if you have a continuous analog signal, right, and you want to get some kind of a gradient, so what do dy by dx, right? But images are discrete objects, okay, they are not analog. So for to get some signal in terms of that okay, what is the gradient for an image, you have to take a kernel. These are some specialized kernels say which can actually mimic the behavior of a gradient. Okay, so this is the gradient in x direction, this is a gradient in y direction. Okay, then again this is a variation, this is just a variation of the above kernel. So this is a gradient in x direction, this is a gradient in y direction. So essentially any deep learning model are built of such kernels, and the, the good part is in deep learning you don't have to manually assign these weights to all the kernels. Essentially these weights are trained automatically using say backward proportion, right? That's the fundamental part. So the fundamental for any image processing or computer vision based systems is kernels. So if you understand these concepts well, you are good to go building more complex things, right? So just for an example, that if you apply this gradient, okay, on this image in x direction, so you get, so basically you see you won't have anything in y direction, you will only have all the edges showcasing in the x direction. Okay, but if you say apply gy, okay, or gradient y, so then you could have some sorry, this is the Sobel operator on the black and white images. So yeah, this is the gradient output for Sobel operator. Now again, same thing. for deep learning based classification, right? So again, here we'll talk about the kernel. Okay, so here you have a 3x3 kernel. You are having a dot product with the original image, and then you are getting some feature output, right? So the thing is, you have these kernel weights, etc., are trained automatically using backward propagation. And when I say automatically, of course, there is a lot of process which goes behind, say, setting up the architecture, tuning the hyperparameters and all those things. But essentially, using backward propagation, gradient descent, etc., these weights are trained, because of which you are able to automatically build features and then get the output. So in any ML based model, it's all about getting features and correlating it with the outputs. Now, the difference is just that in machine learning based systems, you have to define the features yourself. Okay. But in deep learning, these features are built automatically, and that gives you, good outputs. That's it. Now, so ever thought about how the deep feature maps look like? For example, let me take you back. So these are the handmade kernels, defined by, say, Sobel operator, or a what was this, Sobel operator and Privet operator, right? These are the handmade kernels, and these are the feature outputs. Okay, but how does the feature maps from a deep learning model or deep neural network look like? So you see, these are some simple features, but as and when you go deeper down the lane, deeper down the layers, these are the kind of features which you get, right? So yeah, that's about the deep feature maps. Image classification is a core task, as we have discussed. These are some building blocks from a classification perspective. So this is a ResNet 50 architecture, pretty famous one. And basically what we're trying to show here is that all these architecture are somewhat inspired by how our brain works or how our brain sees, right? So from using these inspirations, people build up the architecture that, okay, perhaps I just don't want to take a feature map or features from a previous layer. I also want to take the features from some other layers also, say 2 layers back, right? That is the primary motivation, and that's how they try to build different architectures, etc. Again, I'm just oversimplifying things because I don't want to go into a lot of details, at least right now. So yeah, then okay, so this is regarding the classification deep learning, or classification based on deep learning. Okay, now second is key object detection, right? As we spoke, there are three major components. Okay, again, going back to basics: classification, detection, and segmentation. So far we have kind of spoken about classification, right? Now we'll focus on detection, and then finally we'll end with segmentation. Okay, so detection, what used to happen earlier? Okay, so if you have a CPU and you just want to run an object detection using classical ML approaches, so again, hog is a feature map. So it basically, the entire process looks like that: you upscale or downscale images as a pyramid. Okay, like, say, downscale by half, then downscale by 1/3, etc. Then again, you break the image down into several smaller chunks, like, say, 8x8 pixel block, etc., etc. And on every different block, you build features which are a hog based feature, which are gradient magnitude and gradient directions. You build them, and finally, once you have these features, you have a simple classifier. It could be any classifier. Say, for example, it could be SVM, or it could be XGBoost. Okay, but this system works pretty well to localize any object within the image, right? So these are one of the earliest form of, say, object detection. Okay, now we have pretty advanced techniques to build an object detector, but it's always good to go back to some fundamentals and learn that how these things have started, because it always gives us more clarity, right? Because deep neural network, I mean, it is very hard to actually understand that what exactly is happening. But if we try to go from bare bone mathematics and image processing, ML, etc., it becomes much simpler to understand and gain some what do you say, intuition, right? Yeah. So now the state of the art, object detector, which is YOLO. I mean, you all would have heard about it, hopefully. But yeah, essentially, lot of components here, breaking down the image, then trying to identify the objects, finally non-max suppression, and getting the final outputs, right? So yeah, the mathematics behind this is very complicated. But yeah, always good to read the research paper if interested. Yep. Then finally, as we have spoken earlier, right? First component is the classification component, which any CV enthusiast must be familiar about. I mean, should be familiar about. They should practice it on how to build the classification models and all those things, right? Then the second component is the detection model, and the final one is the segmentation. So you want to identify exactly how the lane is structured. Okay, lane in the sense roads may be, where is the lane mapping going on, so that you could identify that where do you have to change the direction of car and all those things, right? So very minute details for masking and everything. So yeah, so in these segmentation models, you exactly get the pixel values, that okay, these are the pixels for say person X. Okay, these are the pixel values or pixel mask for a bus or a car. Now, segmentation model has its own use cases, but most of the time, like say in production system, if you say that okay, I actually don't need exact pixel values of where a person is, I'm just fine with a bounding box, that okay, this is an approximate location where a person is, I don't really want to segment. So that is why uh, in production system, at least, I have never used a segmentation model because they are extremely slow. Okay, because when you go into production, you have to think about all the performance, scaling, latency, throughput, everything, right? And segmentation model doesn't really meet the business requirements. So it is good to know that how to build a segmentation model, etc., but not necessary. That's what I would say. Then there are a lot of other components also, like say landmark regression, pose estimation, right? Many things are there, but essentially these are some major things which I wanted to cover today. I mean, if you are familiarized with these three building blocks, then you know you are good to go building some really advanced and complicated systems. So yeah, I think that's it from my side. Yeah, any questions?
Sir, you can access the question and access in the Q&A section.
Okay.
Can you access it, sir? Q&A section?
Yes, I can see that. So just a second. Uh, can you help me in what questions you would want?
Sure. I'll read out the questions to you. Okay.
Yeah.
Monale Roy asked, how does data analytics in research sector mostly create presentation of AI and machine learning based conjugate equipment in consumption optimization of RPA consolidation and collaborate data initiative prohibitionary?
So I didn't really get the exact question. So is it related to RPA etc.? Because I don't really have much experience on the RPA side.
Sure. Okay, let me go to next question, sir. Okay, before we proceed to answer, I'll also launch a poll. Okay, sir, is that fine?
Yeah, sure,
Yeah. Hi guys, I'll launching a poll. Please do participate in the poll. Okay, it is about the feedback of the session.
Yeah, so Naveen has asked that first we have to sorry, Yeah, so Naveen is asking that first we have to do segmentation followed by object detection. So no, that is not the way. So if you have to define the use case that do you really, I mean, you really need the localization or the location or coordinates of a person, you or you need the exact pixel value. Okay, so if you are fine with, okay, I just need the xy coordinate of where a person could be, then you don't really need a segmentation model. Okay, because segmentation model is too costly. So yeah, it's too costly in terms of computation, right? So wherever possible, don't use a segmentation model, just use an object detector model. So yeah. Is there any transformer framework used in Pioneer search engine? Asked by SM. So no, this was, I mean, I built this back in 2020. There was nothing kind of a vision transformer available back then. I used barebone CNN architectures and classifiers and detectors, etc. But yeah, so essentially what I would like to tell everyone is that don't just be overwhelmed by, oh, now I have a new framework which is a transformer framework, let's dump CNN frameworks. Okay, that is not the way. Basically you have to try to understand ki, okay, transformer framework hai, theek hai, what kind of problem is it solving? Is it solving a classification problem, or is it solving a object detection problem, or is it solving a segmentation problem? Okay, so first you have to try to understand ki what problem you want to solve. Okay, and then there are many ways to tackle that problem. Okay, transformer could be one of those ways, right? But that is not the only way. So it is good to know everything, but maybe we can take some other session on, say, how to do model optimization, how to choose an architecture and all those things. But yeah, essentially it's not very important whether you use a transformer or a CNN network, etc. Secondly, like Vivek Kumar is asking, we will be shown example of computer vision also means coding or architecture. No, I think this is some other kind of question. Is the code available in public GitHub? No, it's generally a private project or a company-based project. So it's not available. Then Lokesh and have you used transfer learning? Yes, yes, good question. So see, essentially any model you train nowadays, okay, it is essentially a transfer learning based. You essentially use transfer learning approaches because it doesn't really make sense to train an entire model from scratch. Okay, just imagine like people have trained say YOLO on millions of data points and for say how many lakhs of epochs and I don't know how much. So the smart way is to just use the backbone of that model as a feature extractor, and then you have to fine tune, for your specific task. So yes, transfer learning is the way to go for any model. Like actually, it I would call it as a foolish thing to train a network from scratch. But yeah, I mean, it is good for learning purpose because you should train some models from scratch, understand the basics of the trade, and then just rely on transfer learning finally for production. So yeah. Anonymous attendee, why are we using two different operators, Sobel and Privet? Can we use just one? So yeah, this was just for educational purpose. That these are some filters which we generally which is used in CV. What is a kernel mentioned during image processes fundamental? Is it theory or vector null space? So essentially, as I explained in the presentation itself, that you know it's an approximation of how do you compute gradients on a discrete data. Okay, so image is a discrete data. If you want to compute gradients on a analog data, say a signal processing problem or something, it's like essentially dy by dx. But even then, I mean, if you have studied any digital signal processing based thing, so there also we always break down an analogous signal to a discrete space, using sampling techniques, etc., and then use approximate gradients on top of it. Because dy by dx, I mean, it's a very heavy operation. So, but using some approximations, you can get exact same answers with a limited cost. Okay. So yeah, what Pratik is asking that what should be the good roadmap to go into computer vision? Yeah, good question. So the roadmap would be, firstly you should try to understand, like, what is an image, how does an what are the pixel values of an image. So essentially it's a numpy array, it's a 3D, numpy array. So just try to load an image, try to just play around with it. And there are very good resources around. Say I'll just type in a few. I mean, I have mentioned in the slide also. Py image search. Okay, so it's a really good website to understand even basics of image processing as well as the advanced things, right? So I think that is one thing. Plus, I would strongly suggest everyone to take up a course from Android, Coursera, uh, for deep learning.ai. So I would actually think that that is a really good roadmap, because the best part about I what I like from Android course was he asked everyone, I mean, in the assignments, to code an entire neural network using pure NumPy. Okay, NumPy array. So basically, in the initial few lectures and few courses, we never used anything like TensorFlow or PyTorch or anything, right? It's just like implement a ResNet 50 using NumPy, okay? Implement a LXNet using NumPy, or implement a XORNet, or XORNet नहीं बोलूँगा, but yeah, XOR classifier or something using NumPy. Okay, so these are the things which, I mean, when I was studying back in 2017, 2018, when the course was launched, I actually wrote all the equations, gradient equations, differential equations, etc., in a proper diary, and I still have the diary. Okay, and that is an investment which you have to make, because see, finally, in real time or in any project, you are never going to write any calculation or any calculus logic or anything. But एक बार अगर वो लिख लोगे ना कहीं पे, एक बार, कभी भी एक ही बार, then it will always fit in your mind, and you will have a very strong intuition. And why is this working, how is it working, why something won't work, so it's all about building an intuition finally. But yeah, at least fundamentals should be clear. So yeah, I would strongly suggest Coursera, because it is a very structured course. So yeah, I like structure. What is a good model for object detection nowadays? Dinesh is asking. So YOLO is the way to go. Okay, I recently saw YOLO V7 being published, and the FPS were like crazy. I think it's almost 300 FPS state of the art. So 300 FPS at a very low latency. So it's really crazy, the kind of research which is happening. So the thing is, for computer vision, since very long time, the only problem was that it is very computationally expensive. Okay, so that is why it was not able to move into production. With NLP models, it is still really simple to build a very good model which can run in real time at huge amount of data. But that is not the case with computer vision based model, etc. So yeah, YOLO V7, I think it's I would say game changing model. And this is just a start. I mean, many more production based model, low I mean, models which could run on, say, mobile phones and everything, with very good accuracy are going to come. So yeah, is it possible to train mass cars in collab? I would say you should try, right? I mean, you should always try. collab में हो जाना चाहिए. Collab में I have trained, actually, in collab I have trained very deep neural networks. So yeah, I mean, see, if you rely on transfer learning, okay, then it is very much possible to train models in collab at very good accuracy. But if you think that you want to train a model from scratch in collab, so no, that is not going to work. Yep. Vivek Kumar is asking, we will be shown example of computer vision also means coding or architecture. I think we have already seen that. Then yeah, I think Saira Murli has a lot of questions. And I was thinking risky Opencv, but I'm confused. See, I would strongly again suggest everyone to just follow Andrew and the Coursera course. That's it. Priyanka Darbari, no, I don't have any GitHub link for these projects. It's a personal project. But yeah, if you really want to connect with me on GitHub, I would actually, give my GitHub. I mean, one of my project, it is having almost 80 stars. So this project I share with everyone. So my GitHub handle name is Raptor NMN. Okay, it's just a fancy name for myself. So essentially, when we were deploying some of our models in production, okay, in NVIDIA-based GPU systems, etc., we always uh, we always convert our PyTorch model to TensorRT, okay, because these are very hardware friendly. I would say basically uh, hardware friendly models, and if you actually want to push PyTorch model to production, especially for CV based products, it becomes a huge pain. Okay, so for any production system, the way to go is like, say, I'll just write in the chat also for everyone. PyTorch, you have a model trained in PyTorch. We don't use TensorFlow so much. I mean, I try to avoid it, but yeah, PyTorch, then you convert the model to ONNX, and then finally you convert it to TensorRT, for NVIDIA based GPU systems. Yep, I have written it down. So PyTorch, ONNX, TensorRT, these are the model compression or model conversion systems which are used generally in every good CV company. After Narsimha Sravana, he's asking that Narsimha Sravana is asking that after the detection segmentation license plate with skew, how do you handle the next process of OCR? So, yep, think about it like, uh, okay, think about it like first you have an embedding layer, okay, which takes the image, converts it into an embedding. Then there is an RNN layer, which tries to take that image feature map and then trains in terms of a sequential process to get exactly the digits. Okay, so uh, I would actually invite you guys to read about CRNN architectures. Pretty famous, but yeah, we have to train some low-level models with these frameworks and architectures, etc. Okay, CRNN means essentially you have a convolution layer or convolution model to encode the image data. Okay, then you have an RNN layer which can translate that and embedding to a text or something like that. Yeah. Pankaj Kulkarni is asking, can I learn deep learning and computation directly without first learning ML algorithms? I think you can do that, but you really need to have a very structured approach. So again, I would say that you should follow Andrew and Dika deep learning.ai course. That's it. So I think that is there. How to get project ideas, data for CV problems. So Pankaj Kulkarni, I'm assuming that you already know good computer vision. So good project ideas, and also again, I would say there are really good blogs around, say, Learn Opencv and Image Search. Okay. In fact, I think okay, I am listing down some resources for all of you. Okay, so you guys can follow these for good project ideas, learning, and everything. So the second blog, which is the Lilwin GitHub.io, right? So I really like the articles from this person, pretty detailed on everything related to uh, AI and stuff, right? So production experience of deploying CV model. I don't really understand the question. Anonymous attendee. Diksha Singhal is asking, as a fresher, is it enough to have knowledge about object detection, classification, segmentation, or more than that? See, uh, I mean, if you have a good knowledge of these three components, then it's great. I mean, you are already, way more qualified than your peers. But again, if someone tries to, if you are saying that you already know object detection, then the interviewer could ask you, "Arey, what is the backbone of that architecture? Okay, what is the dimension of the layer X and Y and all those things, right?" So whenever you say that, okay, you know an object detector, say YOLO architecture, okay, then you should be prepared to answer some very detailed questions for that particular architecture. That is what I'm saying. Okay, just don't ever say, I just took a pre-trained model and I did an inference, so I know the object detector model. Okay, I mean, if you tell me or tell anyone else, ki, Acha, you have just done the inference using pre-trained architecture, I mean, you will not be considered ever. Okay, so yeah, can we have the GitHub? Can we have the presentation and GitHub link? So yeah, I mean, I will share the presentation with the moderators, and probably they could share share it with you all. So Logic Bobby is asking, sir, what projects beginners should have? So again, as I've answered in the chats also before, uh, but a lot of questions are already repeated. So I'll skip few of them. Pratyusha Goyal, how should we strategize learning traditional CV and state-of-the-art methods? So इसमें strategy तो कुछ नहीं है. I mean, करते जाओ तो आता जाएगा. That's it. That's how I would say. First, start from few basics. At least, for example, how do you load an image? How do you read an image? Writing on an image? All those basic things. I mean, you should be very hands-on with images, etc. Then you can think of, say, deep learning model, etc., etc. So yeah. Sir, why segmentation isn't the first step followed by detection and classification? So, I mean, if you are already doing segmentation, so you have already localized the object, and at the same time, you have said that, okay, what pixel are belonging to which class. So, segmentation is like a mixture of everything. Okay. So, it actually doesn't make sense to do a detection on the segmentation output. I mean, you already have the localized object data. So why would you waste compute on that? Anyways, yeah. So Odambar Panchal, how can we build the model where no person in the video should detect as a no person? And if a person come, it should detect a person and assign an ID. Yes. Yeah. So this is essentially an object detection plus tracking problem. Yeah. More than anonymous attendee. What is the importance of Opencv in computer vision? Opencv is everything in computer vision. Essentially, how do you read a data? So Opencv is the library for reading and writing images, for the computer vision world. But yeah, once you have the data, once you have it in NumPy format, then you can use any other framework or any other library which can essentially compute on top of NumPy data, etc. So yeah. Kiti Vardhana, I have ever seen YOLO V2, 3. Are these versions having different functions? So, see, YOLO is a series. Okay. Okay, I will also like to give you one website. You all should read, understand this website, and probably also look at the code. So, YOLO framework entirely has been written in C++. Okay, and this was started by PJ Reddy. Okay, he's a very famous person in computer vision world. And what you're seeing now, YOLO V2, 3, 4, 5, 6, 7, etc., etc., are just, I won't say just, but are an improved version of earlier version. An improved version in the sense, not just accuracy, but runtime also. So the reason why YOLO became very famous was runtime. So until YOLO came out, all the detectors were very slow. Okay, and because they were very slow, no one could really think of moving it into production and all those things. So YOLO essentially changed the game. Okay, and then we have a lot of good models, etc., who have been built on top of it. So yeah. Mm, Yeah, I think most of the, yeah, George is asking why use PyTorch instead of TensorFlow. So it's a personal preference. See, framework actually does not matter. What matters is the architecture. So you can train a ResNet 50 in PyTorch also and in TensorFlow also. Then the question would come is that, uh, sorry, what I was saying. Yeah, architecture matters a lot more than the framework. So essentially, it drills down to what framework you are more comfortable. Okay. Uh, so if you even if you read the trends now, everyone is just using PyTorch. I mean, very few people actually use TensorFlow. So PyTorch is gaining like crazy over TensorFlow. So yeah, essentially it has a lot of issues around backward compatibility and all such stuff. Also, the learning curve is pretty high for TensorFlow versus PyTorch. So yeah, deep learning frameworks, TensorFlow, PyTorch. Uh, Ivan is asking what models are available for edge detection. So for edge detection, you don't really need any model. It's like a canny edge detector tool, which is essentially an image processing technique, right? So yeah. So yeah, I would like to ask the moderator that do we have anything else?
If any question, if all the questions are answered, then we don't have one, sir. We'll just go.
Yeah, I think it's all done.
Yeah. Okay, sir. Really, thanks a lot, sir. On behalf of Analytics Vidhya, I'd like to thank you for your time and for delivering such a wonderful session, sir. The session was really interactive. I am sure that our audience must also found it insightful, and hopefully we will conduct more such sessions with you in the future, sir. Thanks a lot, sir.
Thank you very much. Yeah, bye bye.
Yes, sir. Thank you. And also for the audience, I'm sharing the LinkedIn profile of Mr. Naman. You can connect with him through LinkedIn as well. And the recording of this session will be available in a few days on our YouTube channel. The YouTube channel link will be shared in few minutes. And if you wish to conduct a webinar or are facing difficulty in registering, connect with us at editor@analyticsvidhya.com. And we will be back with another session of the Data Hour on 29th July. The link is in the chat section. Till then, bye-bye and keep learning. Thank you, sir. Thank you, Mr.
Bye bye.
Yes, sir. Okay, guys, thank you all for joining. Let's wrap it up.